My name is Paul Negulescu, and I am a Senior Vice President of Research at Vertex Pharmaceuticals. Our work in cystic fibrosis goes back over 25 years, where we've been conducting research to discover small molecules, which are tablets or pills, that a patient could take to restore the function of the defective protein that causes cystic fibrosis. For many years, the ability to restore the function of a protein that was caused by a genetic defect was believed to be impossible. Where we are right now is with medications that can treat about 90% of people with CF.
Receiving the Canada Gairdner International Award, incredible honor for me. I'm overwhelmed. It gives an example of what people from all over the place, all over the world, working on a problem, what they can do.
This is a very prestigious award, and what I was particularly excited about in the award was it was for our entire team. It is the work of thousands, literally thousands of people, and I'm so proud to represent that team. And finally, it's meaningful to me because the gene itself was discovered in collaboration between Canadian scientists at SickKids in Toronto and scientists in the US at the University of Michigan. And so that reach across the border and the importance of Canadian research in cystic fibrosis makes it also very meaningful to us.
I think the way we approached the cystic fibrosis problem was with the end in mind, right? And that was, let's fix the broken protein. Let's fix that protein that Mike had done research on and showed that actually it is fixable with that low temperature experiment. And we just worked ourselves backwards from that. If that was the goal, we just said, what are the steps to get there? And I think sometimes what happens, at least in some of the biopharmaceutical research, is there is the temptation to take shortcuts. There is a temptation to just work on the nearest, easiest problem to solve. But I think if you turn it around and say, what's the end goal in mind, you can bridge from the near to the long term. And that's what we did, and it's a very rewarding process to be able to go through that. If we could understand the cause of more human diseases, if we think about it, there are thousands of human diseases, and we actually don't know the cause of many of them. And as a result, our medications that we try are kind of trial and error. It's hit and miss. So to me, a big question is, can we be more precise in our treatment of human disease? The second one that I think I'd like to see if we could tackle would be, can we accelerate the design of drug process? You mentioned AlphaFold. You know, the promise of that technology is that we can visualize any protein, and the next step would be, can we visualize a medicine that could bind to a location in that protein? Can we design that in silico in the computer and just make it the first time, so we don't have to go through the 20-year process that we did to find the CF meds? I'm very goal-oriented, and I think as I look back, I wish that I had enjoyed some of the steps along the way a little more. So celebrate the small victories, celebrate even the failures. As long as you learn from them, they're important.